Let's talk about triangle law of vector addition. Now, triangle law of vectors states that if two vectors are represented by the two sides of a triangle taken in order, then their sum or their vector sum or resultant is represented by the third side of the triangle taken in opposite order or direction. So now, to analyze this, first we know that a triangle will have three sides. So this is a triangle, 1, 2, 3. You have three sides. And 2, a vector will have arrowhead. So now, let's go with the definition and the law. Triangular vectors say that if two vectors are represented by the two sides of a triangle. Now, I'm representing my triangle as this is one side. See the arrow here to represent vector. This is another side. So are represented by the two sides of a triangle. So let me call this place AB. Then here is C. So I have two vectors now, vector AB and vector BC. So now if two vectors are represented by the two sides of a triangle taken in order, that is, they are moving in the same order, as in like that. So opposite order will go in opposite direction to that order. So that's it. So now if two vectors are represented by the two sides of a triangle taken in order, then their vector sum or resultant is represented by the third side. Normally I should have a third side now to make it a triangle. So I should have a third side that will make it a triangle. So it's represented by the third side taken in opposite order. So instead of it to come this way, that is following the same order, so like this, like this, like this, so instead it will rather go this way, opposite order. So it can't be in that order again, so it will rather be in opposite order this way. So and that's what the law is saying. So and that is just triangular vector addition. So it states that if two vectors are represented by the two sides of a triangle taken in the same order, then their third side taken in opposite order represent their resultant. That's all. So that is what triangular vector is saying. So now this place, if this place is A, vector A, and here is B, then here should be A plus B. So that is their sum. That is the vector sum. But we call this the resultant. So resultant here is also the addition of all the vectors. So now if you follow this order of these vectors, we have vector AB, as in from here to here, vector AB plus, and remember vectors you name it from bottom, that is from tail to head. So if this is CD, this is vector CD. So if you turn it upside down, so that will be, if this is C and this is D again, then this is DC. So you name it from bottom to the top, so that is tail to head. So in this case now, vector AB plus vector BC according to the arrow, so will give us vector AC, as in C, from here to here, tail to head, AC. So now look at a pattern here, AB, BC. Do you notice the inner alphabet are equal? So now if the inner alphabet are equal, then the resultant is AC. So look at this now. So A, C, so that is this B are equal, then the resultant is AC. So as you can see, that is why our resultant is AC. So now this will be useful even without drawing anything. You can also know resultant of a vector by just addition. So now let's see question example. So let me say, what is the resultant? So let's just solve different resultant and see. Let me say I have this. Let me say I have something like this. Please always follow the arrow. This arrow is not here. Please follow the arrow. The arrow matters. So let's say this one is this, like this. like this. So let me label P Q R S T. So now what is the resultant of this vector above here? So now if you see all this line like this, follow the arrow. Do you know this is PQ? So if we follow the arrow, that is PQ, like the way the arrow is moving, plus vector QR, that is QR, plus vector RS, so like that, plus vector ST. Now what is the resultant now of this vector? So you will notice this one and this one are alike, then this will be PR. Remember, if they are alike, the resultant is this one and this one, PR plus now RS. So I've resolved these two now to 1, so plus RS plus ST. Now resolve these two again, so this will still go, that will be PS plus ST. Now resolve the last one, so that is PT. That means the resultant of this vector here is PT, and that is their vector sum. So now let's see another aspect. So this will help us in solving some questions later. So but we are still doing the part. So after this video is calculations. So now the next one is, let's say we have something like this. Let me just sketch. So let's say I have something like this. Now my arrow, once I have this. So now if here is A, B, C, D, E. So call this place A, the length B, C, D, E. Now what is the vector sum of this vector above? So now to find the vector sum, follow the arrow. Anywhere you start is allowed, but follow the arrow. So now if I'm starting here, AB, so I'll follow the order. So that will be AB, follow the arrow, plus BC, plus CD, plus DE, just follow the arrow, plus EA. So now let's find the vector sum now. So you see this and this are alike, then we resolve this to AC plus CD plus DE plus EA. So now this and this again are alike, so it's AD plus DE plus EA. So that means if you see any diagram in vector, you can actually resolve it to know which one will be a resultant. So this one again, AE plus EA. So E will go again, that is A. Now this one means the vector starts from A and end in A, and that is 0. So the resultant here is 0. So to make it visible for better understanding, so I have AE plus EA. Now do you know if I reverse this EA to AE, it will be minus, that is opposite direction. So this will be like AE. So if you are now changing EA to AE, then you know it's EA, then it must change to minus AE, as in opposite direction. That's what it means. So AE minus AE will be 0. So it's visible that way to see that is 0. So and if a vector starts from a point and still end up there, then it's 0. Resultant there is 0. So now that is for this one. So now let's say we have this. Find the vector sum of this vectors. So let's say I have AB plus BC minus DC minus AD. So now find the vector sum here. So I can see that AB is the same, then this will be AC minus DC minus AD. Now to make this, this is C and D, it must be CC, and here must be addition, but I don't care about that. Let me just walk through the normal process. So I have to say minus. Now if I'm reversing this CD and DC to CD, then it must be minus CD, because you have changed the direction like that. DC have changed to CD, then it's minus. So this minus is still in the question. So now minus AD. So now this will becomes AC plus, so minus times minus plus, so CD, then minus AD. So we can see now that this one and this one are now in, then this will be AD minus AD. So and that will be give us 0 direct. So remember, anytime you are changing vector from one form and you are reversing it, then this is minus AE. Take notes. So now that is how you can resolve vectors even without drawing the diagram. And I have already proved all the formulas for the resultant of vectors in a video, that is R is equals to square root of P square plus Q square plus 2PQ cos theta. That is the resultant if we have number. Now this one is resultant if it is just the alphabet. Just want to know which one will serve as resultant. So in any number of vectors to find the resultant. So now in next video we'll now do calculations. So then try all this. Find the resultant of these vectors. So we have, let me say I have PQ, QR, RS, ST is equals to what? And according to this law, the law of triangle, law of vector, you can actually trace which line can be a resultant in any number of triangles or any line. So if I have a triangle of this form, now look at this triangle very well. Which line can be a resultant here? Now if you look at this order, one is going this way, one is coming this way, so instead of it to continue this way, is now this way. That means this line is the resultant of this triangle. So merely looking at it, you can know which one is the resultant. If the order change, then that one that change is the resultant. Yeah, what is the resultant of this vector? So this one move this way, this one move this way, this one move. So everything is in the same order. So the resultant will be 0. But if this one or anyone like this, so if you see this one move this way, this way, this way, instead of it to go this way, is now this way. So this line will be their resultant. Now if I don't want to do it that way, then I have to represent all the points as alphabets. So anyhow, so if I call this place A, B, C, so what is now the resultant like this, even without looking at it? So this will becomes BC. So see BC like this. Do you know this should be CA moving upward, but instead it's not upward, it's plus AC. So what I'm doing is that, see the arrow, I've told you follow the arrow tail to head. That's how you number vectors. So now see BC, this is tail, this is the head, moving in that direction. CAC is in this direction, so don't just label anyhow, so you need to follow the arrow. So now this is BC plus AC, then plus BC. I can actually add anyone first. I can take AC to first, anyone, but I'm sure that this is tail head, and tail head. So now with this we can find their resultant. So now if you look at this very well, then this can be BC plus BC plus AC. like this. So now if you look at one, there is a mistake here. One is not BC, as in here to here is BC plus AC, then plus BA. Sorry, this is not BC, so BA. So because this is still edge, BC plus AC, then plus BA, as in that's it. So now I'll take this one like BC plus BA plus AC. So now how do you think you can resolve all this? So now arrange it to be like something like this. So arrange it. So that means we can have BA plus AC, so plus BC. So I'm arranging in such a way that this and this will be alike. So that is BA plus AC, so that I can have BC here. So I can have BA plus AC. So that will be BC, then plus BC. So this will be 2BC. So if I add the two together, so that will be 2BC. So and if you still use the other way, that is you follow the arrow, so this will be BA direct, as in if you follow the arrow in the same order, plus AC, then plus BC according to the arrow. So if I change the arrow, so that's how everything is. So let's stop there.